Calc, here we go. Unit 3, Lesson 4. This will be broken up into a couple parts. Our goal is to solve exponential and logarithmic equations. In this one, we're just going to work on exponential, solving exponential and logarithmic equations. So, again, if I kind of have a few quick examples. Okay, so first one, 2 to the x equals 32. Again, my goal is try and figure out, well, what's x going to be? I know that 2 to the x would be like the same thing as saying 2 to the 5th, which would equal 32. Therefore, x equals 5. If I had a natural log, say ln of x minus ln of 3 equals 0. Again, because I know that it equals 0, ln of x is going to equal ln of 3, because 5 minus 5 is 0, 2 minus 2 is 0. Therefore, ln of 3 minus ln of 3 equals 0, and x equals 3. Part C, if I look at 1/3 to the x equals 9. Again, I could rewrite it as 3 to the negative x equals 3 squared, because 3 squared is 9. And so I can see that in this case, hey, x is going to equal -2. Remember when we do this, okay, again, because it's a negative exponent, my number is actually getting smaller. E to the x equals 7. I could rewrite this as the natural log of e to the x equals the natural log of 7. Therefore, these two cancel out, so x equals the natural log of 7. Again, remember that ln and e are inverses, so they're going to cancel each other out. If I have the natural log of x equals -3, I would rewrite this and say, okay, I'm going to raise it. E to the ln x equals e to the -3. I'm raising both sides, or I'm using e on both sides. But again, these two are going to cancel out. Therefore, x equals e to the -3 power. Just like the previous example, the natural log and e are inverses, so they cancel each other out. Log base 10 of x equals -1. I could raise this to, or use 10 as my base, and then raise this up into my exponent. Equals 10 to the -1. And again, because these are going to cancel out right here, x equals 10 to the -1st, which is the same thing as 1/10, because a negative exponent gets smaller. So again, strategies is you can rewrite your original equation so that you have something that's more usable. Looking at 1-to-1. You can rewrite an exponential equation in logarithmic form and apply inverses, or you can rewrite a logarithmic equation into an exponential form. So again, to use the inverse and to cancel some stuff out. A couple more examples here. Let's say solve each equation. Let's do 2 examples here. E to the x equals 72. So if I wanted to solve this, again, my goal is to try to figure out x. I'm going to say, well, the natural log of e to the x equals the natural log of 72. Again, ln and e is going to cancel out, so I'm just left with x equals the natural log of 72, which, if I use my calculator, is approximately 4.277. We could check this into the original equation. So again, if I put e to the 4.277, I should get 72. Let me type that into my calculator right now. Okay, so let's see here. Function, give me e to the 4.277, and I do get approximately 72. Again, it's not going to be exactly the same because, again, we are rounding our answer. Second example, 3 times 2 to the x equals 42. So I know, hey, I'm going to start by dividing by 3. Therefore, 2 to the x equals 14. I don't know what that is off the top of my head. So I'm going to say, well, I'm going to use log base 2 of 2 to the x equals log base 2 of 14. 2 to the 2 to the x, this is going to cancel out right here. I'm left with x equals log base 2 to the 14th, which we don't necessarily like it if it's not a base 10. It's harder for our calculators. So we're going to use our properties and say x equals the natural log of 14 over the natural log of 2. And again, I can use my calculator. Okay, so I have, if I go to my functions, I say the ln of 14 divided by natural log of 2. And I'm going to get 3.807 approximately. So I'm just going to round that and say it's approximately 3.807. Could double check this by plugging it back into my original equation, and I should get an answer pretty close to 42. Okay, moving on. Solving an exponential equation. So let's say that we have 4e to the 2x minus 3 equals 2. So first off, I'm going to say, okay, I'm going to start by adding 3 on both sides. So I'm going to get 5. And then again, I want to think about, my goal is to get x by itself. So I'm going to divide by 4. So e to the 2x equals 5 over 4. Then to get rid of e, I need to use the inverse, which is the natural log. So I'm going to say ln of e to the 2x equals ln of 5/4. Again, this is going to cancel out, so I'm just going to be left with 2x equals ln 5/4. And then I can divide by 2. And so x is going to equal the natural log of 5/4 over 2, or the natural log of 5/4 times 1/2. Same thing. So again, take my calculator, function natural log of 5 over 4. Use my parentheses, oops. And then I'm going to multiply it by 0.5, same thing as dividing by 2. And I get an answer of 0.11157. I'm going to round that to 0.112. Again, approximately. Squiggly equal sign means approximately. So here are 2 more examples for this video. Solve 3 to the 2t minus 5, all in your exponent, minus 4 equals 11. Again, just for starters, let's get rid of that negative 4. So 3 times 2t minus 5 equals 15. And then divide by 2, divide by 2. So I'm going to get 2t minus 5 equals 15 over 2. And because I want to get that number out of my exponent spot, it's hard for me to deal with that when it's in the exponent. I'm going to use log base 3 and then raise everything up here. And so these are going to cancel out. And again, if I do something on the left, I have to do it on the right. So this is going to cancel out. So I'm going to be left with 2t minus 5 equals log base 3 of 15 over 2. 15 over 2 is really 17 or 7.5. So let's just change that. Again, it's half of 15. So I'm going to start by taking this minus 5 and adding it to the other side. Log base 3 of 7.5 plus 5. And then to simply finish this off, I'm going to divide by 2. So t is going to equal Again, dividing by 2 is the same as multiplying by 1/2. Log base 3 of 7.5 plus 5 over 2. So I could plug this whole system of equations into my calculator and get just, again, a helpful note, because we've got this base of 3. We don't like having base of 3, so we're going to rewrite it as ln of 7.5 over ln of 3. That's kind of our workaround to not having to use a base of 3, because our calculator automatically goes to base of 10. Now, if we do look at it, let's see here. Maybe we can manipulate it. Yes, it looks like our calculator is in base 10. So that's why we have to do that. So let's see here. What did we get? 5 over 2 was 2.5. We can just write it exactly the same. 5 over 2 plus, again, I rewrote log base 3 of 7.5 to ln 7.5 divided by ln of 3. So function, I'm going to say the natural log of 7.5. We got to use parentheses here. Divided by the natural log of 3. Ooh. Okay, that should be good. I got 4.334, but I forgot, if I look back at my original problem, I forgot this 1/2. So I have to change that. Use my calculator again one more time, and I'm going to multiply this statement right here. And I need to multiply this by 1/2. So I get 3.417, which is correct. Again, it's approximately. Last example. Okay, did I say that was the last one? I lied. We got one more. Last one here. E to the 2x minus 3e to the x plus 2 equals 0. So what I'm going to start by doing is just manipulating my variables. So again, I can rewrite this as e to the x raised to a power of 2. Remember your exponent rules. A power raised to a power means you multiply. And because I have it written like this, I can manipulate it even more and say, okay, I'm going to have e to the x. I'm going to factor it out. E to the x minus 2. So again, if this is just looks like something you would have done in algebra 2, x squared minus 3x plus 2, you would say, hey, that's x minus 2, x minus 1. Well, we can use that, but instead of x's, we have e's, e to the x. So e to the x minus 2, e to the x minus 1 equals 0. So again, zero product property, anything that multiplies equals 0. So e to the x equals 2, or e to the x equals 1. Which, again, if I don't like using e to the x, I can call it, hey, ln of e to the x, ln of 2. This is going to cancel out. X equals the natural log of 2, or x equals the natural log of 1. The natural log of 2 is approximately 0.693, and the natural log of 1 equals 0. So these are our two answers.